good morning, my dear students. I'm Daphne Cole. Welcome to my STPM chemistry discussions. In this video, we'll discuss about the questions from the mass spectrum. So, you need to know what is molecular ions and fragmented ions. Then, how to calculate the percentage abundance of the ions. Now, let's go to the first part. What is molecular ion and fragmented ions? My dear students, mass spectrometer is a technique used to determine the information about the chemical structure of a sample. Mass spectrometry uses a beam of high-energy electron to break a molecule into fragments. Therefore, the principle involved in mass spectrometry is the formation of several ions from the sample. The mass spectrometer converts the compound to ions so that they can be moved about and manipulated by external electric and magnetic field. It consists of 5 basic parts. At first, mass spectrometer ionizes the sample into gaseous ion. The ions are separated according to the ratio of their charges to their respective masses, and then records the relative abundance of each ion type. The results are represented as a mass spectrum. The uncharged particle won't produce a line on the mass spectrum. These uncharged particles get removed by the vacuum pump. Only charged particles will be isolated, deflected, and detected by the mass spectrometer. In this topic, students need to know the basic information of mass spectrum. There are different types of mass spectrum peaks which are produced from different types of ions. However, in STPM syllabus, students are only required to know molecular ion, fragmented ion, and N++1 ions. Always bear in mind that from the information of molecular ion peak, we can determine the molecular mass of the compound, while the structure of molecule or sample can be deduced by analysis of the fragmented ion by looking at the smaller peaks produced by the fragmented ions. It's important to realize that the pattern of lines in the mass spectrum of an element tell you something quite different from the pattern of lines in the mass spectrum of an organic compound. In a mass spectrometer, sample molecule X in vapor state are bombarded by fast-moving electron and positive ion are formed. This ion is called the molecular ions or parent ion, and it given the symbol of M+. Molecular ion is the whole molecule except for one electron of almost no mass. However, a molecular ion is unstable and undergoes fragmentations. The molecular ions broken up or decomposed into many fragments. Therefore, many peaks can be produced. Now, let's go to the questions example 1. From the questions 1A, we need to determine the chemical formula of compound Y. So, the first step is determine the empirical formula of compound Y first. Then we transfer all the information given into the following table. Lastly, the empirical formula of compound Y is equal to NH3. Next, to determine the molecular formula of Y, we need the information of relative molecular mass of Y. The peak with the greatest m over E is at 17. This peak is due to the molecular ions. This tells us that the relative molecular mass of compound Y is 17. Now, let's look at questions 1b. The molecular ion formed from the ionization process is unstable. It will break into the following fragments through fragmentations. Since the sample consists of isotope chlorine-35 and chlorine-37, so these are the sample of chlorine dioxide molecule. After ionizations, these are the molecular ions produced. These molecular ions are unstable and decompose into different fragments. That's all for today. See you again.